You know, when you write a line of code, it feels a bit like magic, right? You type a command and then poof, something happens on screen. But what's really going on behind the curtain? Today, we're going to pull that curtain back and trace the exact journey your code takes, from a simple text file all the way down to the computer's processor. I mean, have you ever really stopped to think about it? That single command you write kicks off this incredibly sophisticated chain reaction. So we're going to follow that chain step by step and see exactly how your idea, written in C#, becomes a real physical action inside the computer's brain, the CPU. All right, every journey has a starting point, and for us, that's a piece of C# code. This stuff is what we call a high-level language, and that's because it's designed for us, for humans, to read and understand. But here's the catch. Your computer's processor, it speaks a totally different language. It has absolutely no clue what any of this means. And this, right here, is the central puzzle we have to solve. On one side, you've got our C# code. It's abstract, it's flexible, it lets us express these really complex ideas. But on the other side, you have native code, or machine code. And that is the only thing the CPU understands. It's just ones and zeros, totally unreadable to us, but super specific and incredibly fast for the hardware. So how in the world do we bridge this massive gap? Well, that bridge is built through a 4-step process. We start with our C# code, obviously. That then gets compiled into something called intermediate language, or IL. From there, it gets translated into that CPU-specific native code, and only then, finally, can the processor execute it. Let's start with that first big translation. So the first major stop on our journey is the C# compiler. Its whole job is to perform that first really crucial translation, taking our human-friendly code and turning it into the special middle ground language called IL. The best way to think about IL is like a universal pigeon language for the entire .NET ecosystem. It's pretty cool, actually. It doesn't matter if you wrote your code in C#, F#, or some other .NET language, they all get boiled down into this one common platform-agnostic format. And this design choice is the absolute key to making the whole system so flexible. Okay, so our code is now in this universal IL format. But it can't just run on its own, right? It needs an environment to live in, a manager to oversee everything. You can think of this next piece as the airport's control tower for our code, and this is the CLR. So what is the CLR, officially? Well, it's the Common Language Runtime, the absolute heart of the .NET platform. It's the execution engine where our IL code gets managed and prepped for its final translation. But honestly, it does way more than just run the code. Yeah, the CLR is kind of like this super diligent manager that's always working in the background, handling all these critical side jobs for you. It's doing garbage collection, which automatically cleans up memory you're not using anymore. It's enforcing type safety so you don't get weird data errors. And it handles exceptions so your program can fail gracefully instead of just, crashing. These services are vital for building secure and stable apps. Okay, so our IL code is now loaded up inside the CLR. We're on the tarmac, ready for takeoff. But wait, there's one last super critical translation that has to happen. And this is where the JIT compiler gets its moment in the spotlight. JIT stands for just in time, and that name tells you everything you need to know. At the very moment, the microsecond, a piece of your code actually needs to run, the JIT compiler instantly translates the universal IL into the exact native code that your specific CPU understands. It's like having a personal, on-demand translator that works at lightning speed. So let's take a step back. We've followed this code from a high-level language to an intermediate one, and finally all the way down to machine code. That seems like a lot of hoops to jump through, doesn't it? But here's the thing. This complexity isn't an accident. It's actually the secret to the platform's incredible power and flexibility. And here's the payoff for all that work. First up, portability. Because the code starts as IL, it can run on any machine, as long as it has the CLR installed. Second, you get fantastic performance, because that JIT compiler optimizes the code specifically for the hardware it's on. And finally, you get rock-solid security, because the CLR is managing the whole show safely in the background. It really is such an elegant process, isn't it? Each step has its own distinct job to do. And the source material we're looking at sums it up perfectly. It says that the source code gets compiled into IL first, then at runtime, the JIT compiler translates that IL into native machine code. It's a perfect partnership, really. The IL gives you the flexibility, and the JIT compiler gives you the speed. all happening inside the safe bubble of the CLR. So this whole journey, this whole process from C# to the CPU, it's what makes modern apps so flexible, so secure, and so portable. But it does leave us with one last really important question to chew on. With all these layers, all this translation and management, is there a trade-off? What do we give up to get all this power?